So let us start today's lesson. If you remember last time I stated the problem but I didn't solve it for you and I asked you to try to solve it yourself. So do you remember, if A and B and C are numbers and we know that the product AB is equal to the product AC, and of course if it is guaranteed that A is not equal to 0 for numbers, A, B, and C are numbers in this case, then I can eliminate A from both sides and conclude that B is equal to C. Yes? That was my question for these new products we learned. So that was the normal product between numbers, but we learned two types of products for vectors. One was the dot product, the other one was the cross product. I want to ask the same question for these two new products. Yes? For example, for numbers, we have this addition, yes, and then of course you know that I can conclude B is equal to C. If A and B are vectors now, and if I add them, I hope that you agree with me that still this will hold, yes? Yes. So for addition of vectors, the same property for the addition for numbers is inherited. But the question is that, do you think the same is true for these two type of products that we have learned? Even for a number multiplied by a vector, do you know if I have lambda multiplied by a vector, B is equal to lambda multiplied by another vector C, and if I guarantee that this number is not 0, then of course again you can conclude that B is equal to C. But now we learn two new products. My question is that if A, B, and C are vectors and somehow it is given to us that this dot product is equal to this dot product, and it is also guaranteed that this vector is not the 0 vector, do you think I can conclude that B is equal to C? I want to ask the same question for the second type of product that we learned, the cross product. And it's guaranteed that A is not the 0 vector. Do you think in this case I can conclude this? If you want to say yes to each one of them, to any of them, you have to have a proof, or if you want to refute it, you need to convince me by a counterexample or something. Yes? So first you need to have an intuition about if the answer is yes or no, and then say why. But that was the problem I stated the last moment of the previous lesson. Let us think about the first one. Do you think the first one is correct? Yeah, don't make it so hard. It's very, very easy, by the way. The answer to both of them is a big no. Yes, but why? And you can draw a picture for me. Yes. So can you give me? Can you draw three vectors for me, as simple as possible? That this one and this one as numbers are equal, but B and C are not the same. So do you remember? From geometrical point of view, dot product is somehow related to orthogonality, perpendicularity, and the cross product is somehow related to parallelness. Yes, so might be that's a good idea. So here, if I keep this vector A and then keep this vector B, which is perpendicular to that vector, and let me consider this smaller one, for example, C. Yes? If I ask you what is A dot B, what is your answer in this picture? 0. If I ask you what is A dot C in this picture?
0.
Again 0. So these two numbers are actually equal, but B is not equal to C. Yeah, it's very simple to understand. It's not understandable. So you see, I gave the three special kind of vectors, and I confirmed that A dot B and A dot C are the same because both of them in this case are equal to 0. But you see that I choose B longer than C. It's clear B and C are not equal. Yes. And the same trick probably you realize will work here. Can you help me for that? But of course, this is related to perpendicularity and this is related to parallelness. Yes. So what should I do? I will draw, for example, a vector A. I will draw a vector B. I will draw another vector C, for example, all parallel. Yes? And then I ask you, what is A cross B? A cross B is the 0 vector because they are parallel. And what is A cross C? That's also the 0 vector. So you see that these two vectors are equal without B and C being equal. So this is not in general true. But the point is now I want to solve a better example. If both of them simultaneously holds, we want to show that B is equal to C. So in principle, let me write this example. It's a good example. Let A, B, and C be vectors such that A is not the 0 vector and both equalities A dot B is equal to A dot C and A cross B equals to A cross C whole. Show that B is definitely equal to C. So you see, both, now I'm telling you that I have a triple of vectors A, B, and C so that both of them are simultaneously satisfied. Then I would say that it is inevitable B has to be equal to C. Yes? Okay, why is that? How do you think we can prove this? Okay, so let us do it like this. A cross B is equal to A cross C. So I can write it like this. I can conclude that A cross B minus A cross C is equal to the 0 vector. And you learn how to factor A out. Here, I don't have any problems with factoring A out because both of them are sitting on the left, but I have to factor it out from the left because I have to keep the order. Okay, and this means that the cross product is 0. So, do you remember if the cross product is 0, there are three possibilities. So there are three possibilities. Either the first one is 0, which is not true because I have mentioned explicitly that A is not 0. Or the second one is 0. If that is the second one is 0, then I am done because I want to show that B is equal to C. If you are telling me that the second one is 0, which means that B is equal to C, no fights, yes? We just have a piece and then we are done. But the third possibility might be the case. We want to rule it out. Okay? So the possibility is that So this tells me that either A is the zero vector or B minus C is the zero vector, or what should I write? What is the third scenario?
A and B minus C are parallel.
Parallel, yes. So this means that A is parallel to B minus C. So not possible. Since A is assumed to be non-zero vector. Okay. If this is the case, I conclude that B is equal to C as demanded. And it means that I'm done. So this means a little bit problematic. I need to think about this third situation. Yes? But do you remember I told you that we have two versions that if two vectors are parallel, we have two things you need to remember. One is that if two vectors are parallel, it means that the cross product is zero. But one we learned much earlier. If two vectors are parallel, one of them is a multiple of the other one. So let us use, so you see that in this problem I'm using both of them. So here, if you tell me that B minus C is parallel to A, and if you tell me that B minus C is not equal to zero vector, because if it is, we are done. If it is not, I can use that theorem, yes? So I would say that, so if B minus C is not zero, then from this condition, I can conclude that there exists a non-zero m, a number non-zero, so that B minus C is m times A. Is that understandable? So this is not zero. If this is zero, I am done. If this is not zero, then the third scenario will happen, and it means that I have two non-zero vectors that are parallel. So it means that one of them, any one of them, is a multiple of the other one. So for example, there exists a non-zero number m, so that when I multiply it by A, it becomes B minus C. Is that right? Okay, now from here, I can conclude that B is equal to MA plus vector C, yes? Okay, now let me multiply both sides by A, by the dot product. So if this is the case, I can conclude that A dot B is equal to A dot MA plus C. Yes? So this means that A dot B is equal to, what can I write instead of this? I can distribute it inside. This M is a number, so it is floating around, then it becomes A dot A. But do you remember what is A dot A? Is the norm of A squared. Yes? And then this becomes A dot C. But I can cancel this one and that one, yes? Because it is given in the problem that A dot B is equal to A dot C. And then what happens, this means 0 is equal to M, norm of A squared, but that is contradiction. Yes? Why? Because this is a number, that's another number, the multiplication is 0, either the first one is 0, which is not the case, or the second one is 0, it means the vector A should be 0. So that's not the case either. So it means that the third possibility cannot work. So it means that only the middle one works, and this means that B and C are equal. So this is a good problem, I think. So you see, in one problem you are using both versions of being parallel, for two vectors being parallel. Is that understandable? Okay, so from now on, if you have both of them true, then you can immediately and safely conclude that these two vectors are equal. Now let us do some geometry. using the cross product. Okay, so let me clean this. There is a nice connection between the cross product and the area. Okay, so let me just try to, and that is the theorem, so let me write the theorem here for you. Let vector u and v be adjacent sides of a parallelogram. Parallelogram. And let S be its area. Then S is equal U cross V its length. So that's a nice, very simple and nice theorem. It's extremely simple, by the way, but it is written in the language of vectors. Yes. So, of course, it is clear that I cannot write. Why this is wrong to write something like this? It's clearly wrong. Why?
Because it's a vector.
Yeah. The right hand side is a vector, the left hand side is a number. A number cannot be equal to a vector. But this equality makes sense, at least. You want to show that not only it makes sense, it is true. Yes? So what do? I will try to convince you by that. For example, assume that you have a parallelogram. And then you have A, B, C, and D. And I have asked you to assume that U and V are adjacent sides of a parallelogram. So it is not the opposite sides. I don't know. For example, you can take this one to be U. You can take the other one to be V, and it doesn't matter if you want to put the tip of the arrow here or the tip of the arrow there, it doesn't matter here. So let me consider this one to be V. You will see that the directions are irrelevant here, because at the end I'm taking the magnitude, so the direction just makes a minus sign difference. Okay, and that is clear. Do you remember what was the area of a parallelogram from geometry? What was the rule with that? By the way, I'm making it a little bit complicated. I don't know why did I choose this one to be. Of course, this is also the same. You don't need to be worried about that. But let me, for the time being, consider this one to be V. This is more natural to be. But it doesn't matter. You can choose that one as well. The area of a parallelogram is its base, the length of the base multiplied by the height. That is the formula for the area of the parallelogram, yes? So it means that if I want to calculate the area from Euclidean geometry point of view, I would write S is equal to length of DC. Then I don't know which symbol I have to use. So let me put a pair of brackets around that and multiply it by height. Okay, and then multiply it by height. Yes? But of course, DC is the norm of vector V multiplied by the height. Okay, now let me consider the angle between these two vectors to be theta. And then I can write something in this right angle triangle. What is sine of theta? Sine of theta is equal to the opposite side, which is h, divided by the adjacent side. Sorry, divided by the hypotenuse. But the hypotenuse is the norm of u, agree? And then what is h then? H becomes norm of u multiplied by sine theta. What I need to plug it back here and then I am done. Yes, because S becomes equal to norm of V multiplied by norm of U multiplied by the sine of the angle between them. But that's exactly the definition of the magnitude of the cross product. And it doesn't matter if you write V cross U or U cross V, because you are caring about the magnitude. The magnitudes are the same, so if you don't mind, let me write them in order, alphabetic order. So that's very simple. Is that clear? So if you want to find the area of this, that becomes, yeah, so that is the area. And of course, if I ask you what is the area of the triangle, so that these two vectors are its sides, then it's half of this number, yes? So if I ask you to calculate the area of the triangle ABC, ADC for example, then it is 1/2 of the magnitude of the cross product of these two vectors. And by the way, this is the nice formula. This is the formula. Do you remember in Math 3C we had an area formula, but we proved it using geometry. But here we can use vector algebra to do that, yes? Because what is the meaning of this? It becomes 1/2 the norm of U, which is this side, AD, multiplied by the norm of V, which is this side. Let me just put a simple dot here for the product, and times the sine of the angle between them. This formula is familiar, yes? If you want to find an area for a triangle, do you remember? Any triangle that you like, for example, ABC, and I don't know, CBA. If I want to find the area of this triangle, I will write 1/2. I multiply two sides, AB, and then multiply it by the sine of the angle between them. So you can find that exactly from this theorem. So that's good connection between this that you learned from vector algebra and the previous knowledge. Okay. So let me give you an example that you can think a little bit about it, and then we go to the next one. So I'm just finding, I'm trying to, for you to understand a connection between something we had before in geometry from a different perspective, a different approach, and what we have right now. Okay, so let me write this question here for you. So let me write example. Let ABC be a triangle whose area is 10 square meters or square centimeters. Yes, let me write square meters, doesn't matter. Okay. If vector x is equal to this vector AB plus AC cross AB plus BC, what is the magnitude of vector x? What is norm of x? Okay, so I will pause the recording. This is a very, very simple problem. I want to wait a little bit for you. Do you have any idea what to do here? The first thing comes to mind is what? You should be very quick in algebra. Yes? That would be AC. So the first thing that it cries out how to solve me is to write AC instead of AB plus BC. Yes? So let us follow the instincts. Yes? So x becomes equal to. For this one, I don't know. If you want, you can also draw a picture for yourself, but it doesn't help that much. Yes? So let me just write AB plus AC, and everyone knows, hopefully, that is the Sine Rule. And then what can I write? I can write AC. That is the first thing, actually, comes to mind, hopefully. Then what is the second one?
Distribute.
Distribute, yes. You see, you need, at this level, you have to have some instincts about how to do things in mathematics. So we have to AB cross AC. And the next one would be, I am not allowed to interchange, be careful. So AC cross AC. Then what would come in next? It is clear now. What's coming next?
AC.
Cross AC is the zero vector. Yes, this is the zero vector. So I'm multiplying a vector by itself, so they are parallel. That's the zero vector. So actually this is simple now. This is this vector only. But my question is about the magnitude of this vector. If two vectors are equal, definitely the magnitude of this vector on the left is also equal to the magnitude of the vector on the right. Okay, but if I want to use the original definition, I need to know the magnitude of AB, which I don't know. I need to know the magnitude of AC, and I also need to know the angle between them, which I really don't know any one of them. But I have a better information in this problem. Yes, I know that the area is 10, and I know that this for the triangle is 2 times larger than the area. So that is 20. Yes, so this becomes 2 area, because area is 1/2 of that. AB and AC are the length, are the vectors, are adjacent sides of a triangle. So this becomes 2s, and it becomes 2 times 10, and it becomes what? 20 meters. Yes? Okay, so that was a simple question. But now let us go to the other one. Of course, you know the content. You had it in Math 3C, in trigonometry, and then later in this course I proved it for you in Euclidean geometry context, but now we want to prove it using vectors, and that is the sine rule. Yes, so what was the sine rule, do you remember? So theorem, let me just review it again. So theorem, the sine rule. So the sine rule tells you that if I have a triangle ABC, and then let me call it A, C, and B, this one is A over sine A is equal to B over sine B. That's a very nice property of a triangle, yes, of any triangle. C over sine C. Yes, this, here we can only prove this. But we went a little bit further, if you remember, when I was teaching you Euclidean geometry. I told you that this is equal to what? You remember something like that? So it is 2 times r. But what is r? R was the, yes, r was the radius of the circumcircle. The circle, the unique circle that passes through all these 3 points simultaneously. This I cannot show using vectors here, but I just want to show that equality between these 3 fractions. Yes, but if you want to know what is the value for that, it becomes the diameter of the circumcircle of that circle. Okay, so how should I prove it using vector algebra? I don't know, let us start with something here. So you know that, so you see that because I have sine here, and sine is somehow related to the cross product in its magnitude, I see a sine. So let me just start doing things. So for example, do you agree that if I add vector AB, so be careful again, there is no vectors involved. I am using vectors to solve that problem. So I will write this vector, I can imagine this vector and this vector. So if I add these 2 vectors, it becomes what? It becomes vector AC. Do you agree? So that's clear. So if I add, even if I don't need the picture, so AB plus AC, AB plus BC is AC. Okay, so do you remember, for the cosine rule, I also use this trick, but I use the dot product, and that was intuitively clear because the dot product is somehow related to cosine. But here I want to say something about sine, so probably I have to cross product something. Yes, But what do you think I should do? Cross product by what? Do you have any idea? Cross product, I have three vectors involved. Do the cross product in a way that you are left with only two vectors. Yes, do the cross product in a way that you are left with only two vectors. Okay, so my question is that instead of question mark, write a vector that after simplification, two vectors are involved. Not probably a good question. Okay, I don't know. Do it. Cross product it by something. Because again, yes.
I mean the height of...
No, simpler than that.
AC.
AC is good one because this will kill AC, but I prefer to multiply this because if I kill AC I need to move this one and I am lazy, so let me keep that way, yes? So let me multiply by BC for example. Yes, that was the AC will also work, but I have to move things around, yes? And they are heavy. So this is BC. Why is that good? Because now what I can do, I can distribute them. Then let me just do that, the second one in my head. What is the second one here? BC cross product by itself is the zero vector. I don't need to write anything. Yes? Agree? And now I will ask you here, if the left hand side is a vector, the right hand side is a vector, I know that two vectors are equal, but my goal is to say something about the magnitudes of the vectors, because A, B, and C refer to the lengths of these three vectors. So it is natural to take the norm from both sides, and this is possible. If two vectors are equal, the magnitudes are also the same, yes? Do you agree? And then what happens? You know the definition of the magnitude of the cross product. It tells you the magnitude of the first one times the magnitude of the second one multiplied by the sine of the angle between BC and AB. Can you tell me what is that angle? I want to see that eventually you'll learn what is the meaning of the angle of two vectors or not. So what is the angle between BC and AB? BC is this vector, and AB is this vector. What is the angle between them is called? This angle is A, this angle is B, this angle is C. Okay, so what should I write? Sine of?
120.
Not 120, you are on the right track. How did you bring 120? You are imagining that this is 60.
Oh, right, it's not.
180 minus B, not 120. Yes, exactly. So this becomes 180 minus B. Agreed? And then let me practice here on the right hand side. So the norm of BC, the norm of AC, but what is the angle between BC and AC? AC is this vector. What is that one? What is the angle between BC and AC?
180 minus 6.
No.
Wait, oh, okay. Oh.
I don't know why you don't learn. It's C itself, yes? Because I am supposed to draw them from the same point, yes? So if I parallel transport it here, this angle is the angle between them, and that's exactly equal to C. So this is angle C. But let us do some simple thing. First of all, whatever this is, I can divide, and this is cancelled. What is a better name for this? The vector notation is a little bit messy, but what is the meaning of the magnitude of vector AB? Magnitude of vector B is simply little c. And then you have trigonometry, yes? What is sine of 180 minus b? Of course, you have done the exam. I hope that you haven't forgotten everything. So what is the answer? Sine of 180 minus b? If two angles are supplement, the sines are exactly the same. So the sine of 180 minus b is exactly equal to the sine of b. And on the right hand side, instead of this messy notation, the norm of AC, I can write b. And then, I'm sorry, I made a mistake here. This is not c, this is sine c. Yes. And this is sine c. And then hopefully you realize that this means b over sine b is equal to c over sine c. Yes. And then of course I can, instead of multiplying by BC, I can multiply by AB this time, and I get another equality, and then all of them will be the same. Yes? Is that clear? Okay. Now, let me see what is a good question here. So this question, I want to tell you about this question in two different ways. First of all, let me write the question here for you and try to solve it together. So example, let me see if I can translate it. Let A, B, C be an isosceles triangle such that AB is equal to AC. And it be and let such that this and triangle such that AB is equal to AC and the median corresponding to, so the median of side AC is perpendicular to the angle bisector of the angle C. Determine the exact value of sine of angle C. And by one English question, do you know that we know what, when I start with L, let I should write B, but do you think that instead of this is I should also write B? This is always, I'm getting confused sometimes. So let's.
No, I think it's is.
Is?
Yeah.
I think it's is, yes. So let ABC be an isosceles triangle such that AB is equal to AC and the median of side AC, B doesn't make sense that much, yes. The median of side AC is perpendicular to angle bisector of the angle C. Determine the exact value of C, of sine of C. This problem is not that hard, but by the way, I want to use GeoGebra to draw such a triangle. It is not that easy, okay? So let us try to solve that problem. Okay, so I will give you 2 or 3 minutes, at least you should have a rough picture. Don't try to make it precise because that's not that easy, but try to do some trial and error to get a feeling of this isosceles triangle with these properties. And then we want to calculate the exact value for the sine of C. Okay, now my question for you, before solving the problem, I give you all the tools in GeoGebra and I ask you to draw the picture precisely. What do you do? You want to draw an isosceles triangle in a way that if I draw one median and draw angle bisector of the other one, they meet at right angles. You have the most precise tool in your hand, better than ruler and compass and everything. So assume that you want to do that. How do you draw that? Because let me just try to show you that if I do it randomly, for example, I don't know if it works or not. So you see, I take this one. I want to make an isosceles triangle. 1, 2, 3, 4. 1, 2, 3, 4. Yes, is that right? Do you agree this is isosceles? Yes? Okay. And now if I want to draw the angle bisector, what do I do? The median of which side I have written, do you remember? The median of AC. Okay, good. So I go here and find the middle point between these two. And of course then if I connect this point to that point, this is definitely the exact median of this triangle. And then if I go here and angle bisector, I choose this angle bisector. And of course, if you see, the angle between them is less than 90. And then it is not that easy to fine-tune. Of course, I can play around with these vertices a little bit, but of course I will change. If I want to make it 90 degrees, now it is more or less 90 degrees, but this is no longer an isosceles triangle, yes? So how do you think I can draw such a picture precisely? So these drawing problems could be quite hard, by the way. Yes, can you tell me?
If you start with the two lines crossing,
Yes.
perpendicular, and then you draw a triangle which...
Yes.
Yeah.
So it means I draw an isosceles triangle.
Yeah, first you draw the perpendicular lines.
Okay, so two perpendicular lines you mean?
Yeah.
So, I don't know, if you don't mind, let me draw one of them here. It's easier. Draw the other one here. How long? Does it matter or
I
not?
don't think it matters. I mean...
Okay, so if you want, if it doesn't matter, so let me change it to line. Yes? This is a line. And then where should I perpendicular? Yeah, everywhere.
Yeah, somewhere.
Somewhere here. Okay, then.
Give me a second.
Jag tror du menar att han skulle rita ett triangel och sen perpendicular och sen på lite.
Nej,
Jag tror det är bättre.
C bör vara en av kommentarerna. So I think you can take...
No, this method I understand what you mean, but this doesn't work. Because the position, because you don't know the relative position of these two perpendicular lines, because you don't know where they intersect actually. It could be closer to A, or it could be closer to B, or it could be after A or before B, you know? That's not that easy. Okay, yes?
Is the angle 60 degrees?
Pardon?
Is the angle 60 degrees?
No. No, apparently this is not a nice number. This is why I asked for sine C. Yes? Okay, let me try to say at least one way I got to find it. So let me, for example, let me draw a line here, line segment, for example, for 3 units here. Yes? Okay. And then what I do, I don't remember, so let me see. So what I did, okay, so I will take a circle with this center, but radius 6, okay? 1, 2, 3, 4, 5, 6, yes? That is...
The first line is 4. It's 4, it's not 3.
Oh, okay, so let me make it small, oops, make it smaller. or I can make this one bigger. It matters that it should be double in size. Yes, so it is 4, so I draw a line, a circle with radius 4, and then what I do, I draw the perpendicular bisector of this line. Yes. Of course, the labels are not good according to this one, but I will draw the picture and change the labels right now. And then I will go and find the intersection point between this circle and that one. And then, hopefully you agree with me that from here to here, the distance is the same. We studied this extensively, if you remember. The distance from E to A and E to B are the same. My claim is that this is your triangle. Yes? And let us check. I go here and find the middle point, and then I will take, this is my median, agree? And if you don't mind, let me take these things away that doesn't distract you. Show object, I don't need that. I don't need this one either. Yes. And this is your, and now let me go and then draw the perpendicular angle bisector, sorry. This is a little bit, yes, it worked. And then let me, if you don't believe, let us see. This is my angle bisector. I find this, and let me find that one as well. And then let me get rid of this show object. I draw this one. Yes, and now, if I have done it correct, I should be able to measure the angle. So I go from this angle to that angle to that angle. Yeah, that is 270 degrees, so the other one is 90 degrees. Yes, if you don't like this, I can go from this direction. So it worked. So what I did, I draw a line, but I draw this, I'm using this as the base. Yes? And what I did, I drew a circle with the radius 2 times larger. How do you think I brought this 2 times larger? So first of all, I want you to feel that it was not easy problem if you don't know where to start, yes? So this is an isosceles triangle, this is the angle bisector, and this is the median. It shows that I have it right. Yes? But why do you think it is the case?
Because the sine rule is also equal to 2r.
What? Can you repeat?
Yeah, because the sine rule you also wrote
Yes.
is equal to 2r.
Oh, might be. I didn't think about that in that way. Might be that also works. But so 2r, is it related to somehow this one?
I don't know if
The circle that I drew was this circle, yes? But that circle is not passing through B, so that is not circumcircle.
No,
It
but
was
I
just
felt like the radius was 2 times.
No, but I suddenly I realized that might be you're right, but I remember that when I drew that circle passes through which points, do you remember? A,
Just
A, C, and this E.
A?
No,
No,
just
just E and C.
Just E and,
C.
E and C, yes. Okay, so that is not
The
the,
A is the
A was the
point.
center.
A was the center, yes, you are right, yes. Okay, I didn't think in that way, but I don't find at least a direct connection. Yes? But the way that I did, this is a very good way. You need to imagine that your picture is drawn and try to find nice properties out of it. And then somehow use it to draw it back. Yes? I don't know, you can assume that the problem is solved and that is your triangle. Yes? What I realized, I could draw a rough picture for myself and then realize that this triangle is an isosceles triangle. Why is that? Because this angle is 90, this angle is 90, yes? And then this angle and that angle are the same. because that's angle bisector. And then this side is common to this triangle and that triangle. So these two triangles that you see here are congruent based on angle, side angle. If they are congruent, so it means that the size here and the size here are the same. Yes? And I know that this is supposed to be the median, so this size and that size are also the same. Is that right? So, and then it means that this size is 2 times larger than that size. So this point should lie on a circle with this center with the radius 2 times larger than that. One locus, you remember we had another locus of that point is the perpendicular bisector. So then I have 2 loci and then I find the intersection point, so E should live somewhere there. And then I can draw that point. Is that understandable? So if we had this before, do you remember we were talking about the locus, and then I told you that there is a strong way to think about this geometrical problem using having 2 loci, so that you can confirm that this E lies on both of them, and then it means that I draw one of them, the other one, find the intersection point, E should be there. Yes? So that is also a good problem, but I will leave it open because we do not have time. I want you to solve it next time. Yes? You should be able to get an exact answer, not for the angle C, but for the sine of C. Yes? So that would be open for the next time. Thank you very much.
Oh.